So today I'm going to be presenting a portion of the Charlotte Harbor National Estuary Program's Oyster Habitat Restoration Plan. The purpose of the plan was to provide a technically sound, consensus-based approach for oyster habitat restoration. Earlier we heard about a lot of the research that's been going on in the area, especially by FGCU and SCCF. So we know that oyster restoration is feasible in the area. We also know some of the limiting factors for it. So what we wanted to do was take that existing information and put it into a larger plan for the entire region. The need for the plan was identified by both the CHNEP and the Nature Conservancy, and the two organizations formed a partnership to fund this work and also to assist in the development of the plan. This was really a collaborative plan between the CHNEP, the Nature Conservancy, and the Southwest Florida Oyster Working Group, which was comprised of over 41 people. Those people came from all different sectors: citizens groups, government agencies, permitters, academia, nonprofits. So everybody was really at the table in the development of this plan. We had 5 meetings over the course of about a year, during which we workshopped a lot of the information that went into this. So like I said, I'm just going to be presenting a portion of it. I'll give you some background information, talk about the Oyster Restoration Suitability Model that we developed, then go into the restoration goals and the next steps. The other portions of the plan are listed here. They include permitting, restoration strategies, all the different methodologies can be used, success criteria, monitoring, pretty much everything you need to think about as you go through and develop a restoration project for oysters. So the first thing I want to address is, why is restoration even needed? Well, oyster habitat is actually the most imperiled marine habitat in the world. It's been estimated that over 85% of oysters have been lost worldwide, and in the U.S., the estimates are about 60% of the oysters have been lost spatially, but 85% of the biomass. So even when you see oyster reefs out there, they're not the same as what they used to be. The biomass that's on the reefs is less. So less oysters per meter squared, maybe smaller oysters. And for South Florida, the estimate is about a 90 to 99% loss of historical oyster reefs. And oysters have been the dominant feature, or one of the dominant features, in the Charlotte Harbor estuaries for approximately 2,500 years. So these are definitely a big player in the system. Harris et al. Estimated about a 39% decrease from 1945 to 1982. And then there's been some other mapping efforts to look and see what the acreages of oysters have been in different time periods. In the 1950s, the estimate was around 2,700 acres, and then in 1999, the estimate is around 250. But I should acknowledge that the area photos that were used were not necessarily taken for the purposes of identifying the locations of oyster reefs. This was a secondary thing to go back and map the reef locations. So there's either no ground truthing or limited ground truthing associated with it. Just to show you on this map, these 3 red circles show reefs that were identified from the 1950s aerials, and then in the 1999, the only bit of oyster reef is down there circled in black. So the best estimate that we have for the CHNEP area is that there's been a 90% loss since the mid-1900s. However, even prior to that, a lot of oysters had already been lost. There's an article in the Bulletin of the United States Fish Commission entitled "The Oyster Bars of the West Coast of Florida, Their Depletion and Restoration." And in that paper, the author talks about oysters in the area, the oyster beds, either being partially or totally depleted over the time period of 25 years. And that paper was published in 1898. So the causes for the loss of oyster habitat include dredging, oyster mining for roadbeds, sedimentation, coastal development, and changes in hydrology, as well as harvest. So when we lose the oyster habitat, we lose all of the ecosystem services. And we heard a bit about this earlier. Oyster reefs provide habitat for numerous fish and invertebrates. They also are the base of the food web and provide foraging habitat for a lot of the important recreational fishes and also a lot of the birds. They're important for water quality. Oysters filter a lot of water. They also bioassimilate nutrients and reduce turbidity. And lastly, they stabilize shorelines. They've been used a lot as living shorelines meant to decrease erosion, stabilize sediments, and they also benefit the adjacent seagrass beds and mangroves by the stabilization that they provide. So in the development of our plan, we wanted to make sure that we could successfully restore. We don't want to be throwing a bunch of money at restoration that's not going to be successful in the end. So we wanted to look at where oyster restoration could succeed. We also wanted to look at where oyster restoration projects can occur. So what are the things that we want to avoid when we're looking at restoring oysters? How much restoration is needed, and how do we get there? The study area was the entire CHNEP estuary area, which ranges from southern Sarasota County down through Charlotte County and Lee County, from Don and Roberts Bays all the way down to Estuary Bay. So it's about 220,000 acres of estuarine area. So when we were looking at the data that we would include in assessing appropriate locations, we needed to make sure that that data was consistent for this entire study area. Later, we broke things down by the estuarine strata, which Judy talked a little bit about earlier. There's 14 estuarine strata. So when oyster restoration projects start occurring, they can be tracked by strata and linked to water quality data and other types of data that we have also associated with those strata. So the Restoration Suitability Model was based on the assumption that substrate enhancement is the appropriate restoration approach. So what that means is there's enough larvae in the water column to populate the area as long as the substrate is there. And we heard that earlier also from Aswani and some others, that if you put that shell substrate out or some other hard substrate out, the larvae will settle on it and grow if the conditions are appropriate. So the factors that were included in the model, we evaluated for the availability of the spatial data, the quality of the data, and also the relevance to the application. So first we'll look at what we considered success factors, things that would drive the actual success of the oysters settling and growing in the area. So the four things that we really focused in on was salinity, this idea of killing floods, which we also heard about in the previous two oyster talks, where we have these very large freshwater events where the flow down, especially the Caloosahatchee River, gets so high that the salinities are dropped below 3 parts per thousand for extended periods of time. Dissolved oxygen we considered, as well as depth. And depth and dissolved oxygen were kind of linked together because below a certain depth is where we really have concerns about dissolved oxygen. Most places in the intertidal and shallow subtidal, we don't really have to worry about low dissolved oxygen. The other factors are are things that we would look at more site-specifically when people actually go out to do a restoration project. These are other things that they should consider that we didn't include in the model. So things like temperature, predators, disease, harmful algal blooms, wave energy and boating, water flow, pollution, and substrate. And some of these things could be considered in the design of the project. For example, the substrate. Even with really silty substrate, there's ways to go about creating a restoration project. You just use different materials. So other things we considered were things that we wanted to avoid. We definitely want to avoid seagrass beds. We don't want to be doing damage to other natural resources. However, oyster reefs are often found adjacent to seagrass beds, and as I mentioned earlier, they can benefit seagrass beds as well. So we didn't want to omit areas adjacent to the beds, just the beds themselves. Boat channels, we want to avoid creating any navigational hazards. And also aquaculture areas. There's several high-density lease areas for clams in both Pine Island and the Charlotte Harbor area, so we want to avoid those as well. Now for permitting, we have 5 aquatic preserves within the CHNEP boundaries. Actually, it's 6. And that covers a large portion of the CHNEP. So we just identify in the plan that a lot of these projects will take place within aquatic preserve boundaries. We don't want to avoid doing restoration within those boundaries, though. And same thing with the sawfish critical habitat. That covers, again, the majority of the CHNEP area. It's shown here on the map in green. So the only region it doesn't cover is up in Lemon Bay. And it's also in shallow areas adjacent to mangroves, which is obviously where most oysters occur. So this is a permitting consideration. As anybody does oyster restoration, they have to realize that they are going to have to go through an extra step in permitting and address how oyster restoration interacts with sawfish. So the model itself works within the GIS software by combining all of these different components. Each component is given a score ranging from 0 to 1. 0 is considered not suitable for oyster restoration, and 1 is considered highly suitable. So to determine the end model score, all of the scores were multiplied together. So we had 5 factors. Each of those was multiplied by the other. And so if one factor is a 0 and is considered not suitable, then the entire area would be considered not suitable. So the final model scores range from 0 to 1, which we then changed to a percent suitability of 0 to 100%. So the first piece of the model is depth, which was used as a proxy for dissolved oxygen. We know in the area that there's reefs around 6 feet in depth, and historically we know that there were submerged reefs in the area. We don't know how deep those went. Okay, that's working, good. So we scored all of the intertidal and shallow subtidal down to 3 feet, we scored as a 1 for highly suitable. From 3 to 6 feet, we scored at 0.8, and anything greater than 6 feet, we scored at 0. And there is some interest in the area at exploring if restoration in the deeper depths is appropriate or feasible, but for right now, we don't really know much about that. So this was the scoring that we settled on. The second thing is seagrass persistence. So again, we wanted to avoid where seagrasses were located, and we also wanted to avoid doing restoration in areas where there had been seagrasses in the past, but but maybe they weren't present for 1 year. So if there was seagrass present for all 5 of the years that we included, then the model got a score of 1. If it was present 1 to 4 years, it was scored 0.5, and 5 years, it was scored a 0. For boat channels, we set the boat channel width at 150 feet, which is the width of the widest channels in our area, and that received a score of 0. And then we buffered the channels by 75 feet on each side to provide a little bit extra space for boaters and also for the reefs as well. They don't benefit by having a lot of the boat wakes and things. And outside the channels was given a 1. And then the aquaculture of these areas, we pretty much just omitted those areas by scoring all of those as a 0 and putting a small buffer around them of 30 feet. Lastly was salinity and flow, and this was probably the most complicated piece of the puzzle. We thought we were going to be able to use some of the contour mapping that's been done, but the way that the data comes out is not perfect, so we didn't want to influence the model by using it. You can see in the map on the right some little bubbles of areas. So that's the data need, is to kind of work on how the data that we have can be used to contour salinities in the area. But instead of using that specific information, what we did instead was just identify the isohalines for the 3 major rivers, the Myakka, Peace, and Caloosahatchee. We looked to estimate the location where we would have those killing floods potentially every 3 to 5 years. So we wanted to omit any of that area. So for the Myakka River, that was at 11.5 river kilometers, which is shown in the picture up there. At the Peace River, it was at 15 river kilometers. And for the Caloosahatchee, we estimated it for 2 different scenarios, 3,000 CFS, which is the ideal case, and 6,000 CFS, which has been more of the reality over the last 10 years. So 6,000 CFS puts it down around Shell Point, which is the area where Aswani's restoration efforts have been. So this is what the results look like. We found that throughout the CHNEP estuaries, there was over 22,000 acres of suitable area, which was 100% suitable for oyster restoration, and at least 100 acres in each of those 14 estuary strata. So there's plenty of space out there for oyster restoration to occur where it's suitable and also where it's not going to interfere with other uses. This is just a close-up of the Charlotte Harbor area. So our restoration goal is to enhance and restore self-sustaining oyster habitat and related ecosystem services throughout the estuaries and tidal rivers and creeks in the study area. We didn't put an actual acreage on this because it's so hard to know how many acres we actually have out there now, but what we do know is that the appropriate amount of acreage for our area is about 1,000 to 6,000 acres. We developed some short-term actions. These are to map oyster habitats within the area by 2020, to design, implement, and monitor the success of pilot oyster restoration projects throughout the area, and to increase public awareness. And lastly, the CHNEP is looking to assist partners in seeking funding for these efforts. And there's a lot of steps that we can use to reach these goals. Again, building partnerships, raising awareness, securing permits is a big thing. Securing funding, monitoring and mapping, and filling some of the knowledge gaps that we have about oysters, which a lot of the partners are working on currently. And that's it.
Wow, perfect. Questions.
We do have time for questions.
Okay.
Ladies and
I'm
gentlemen,
rushing through that.
here comes Bob.
Good to see you. I wanted to ask you about the availability of shell or suitable substrate and its proximity to the areas that might be used for restoration. Did y'all look at that? And is that a factor?
It is a factor, and that's something that the Nature Conservancy Conservancy is working on right now. You're going to hear from Andrea in a couple of talks, and she'll be talking about a project that's happening locally. She has been having a little bit of a problem, I hear, in getting some of the shell. There's been some efforts in other locations to do shell recycling by partnering with restaurants and having them keep the shell that's discarded. So that's something that could be looked into in this area.
More questions?
Thanks very much.